Hi Algebra students, welcome back to 12.6, Rational Expressions with Like Denominators. To add rational expressions, recall that to add fractions with like denominators, you add the numerators, then write the sum over the common denominator. You can add rational expressions with like denominators in the same way. So if we look at example 1, oops, we don't need that anymore. So there we go. If we look at example number 1, we have the expression 3n over 12 plus 7n over 12. What we just read said you can add rational expressions with common denominators by just adding your numerators. So we have a common denominator of 12, so we don't have to worry about that. So we just say 3n plus 7n over 12. 3n plus 7n is equal to 10n over 12. And you can pull out some common factors. 2 goes into both of these. 2 goes into 10 5 times. 2 goes into 12 6 times. So you're left with a reduced fraction, 5n over 6. Nice and simple. Sometimes the denominator of rational expressions are binomials. As long as each rational expression has the exact same binomial as its denominator, the process of adding is the exact same. So let's look at example number 2, where we're just adding binomials with the same denominator. So we're told to find the sum of 2x over x plus 1 plus 2 over x plus 1. So easy enough. We see that we have common denominators. If we have common denominators, we just add our numerators. So we have 2x plus 2. Now remember, your job is always, always, always to look for a GCF that you can pull out. And in our numerator, you can see we have 2 in front of both numbers. It's our coefficient and it's our constant. So let's try pulling out a GCF of 2. If we pull out 2 from our numerator, we're left with x plus 1 all over x plus 1. And now you see you have some easy canceling. You can cancel x plus 1 out of your numerator and denominator. And after you simplify the expression, your final answer is just 2. All right, example 3. Find the perimeter. Geometry. Find the expression for the perimeter of the following rectangle. So they're going to give us a rectangle with some missing pieces, but that's okay. We have a side length of 2a plus 3b all over 3a plus 7b. And then our width, which I'm just going to put down here, is 4a plus 5b over top of 3a plus 7. And again, convenient, we have matching denominators. So perimeter is equal to twice our length plus twice our width. So if our length is 2a plus 3b over 3a plus 7b, let's go ahead and fill that in right here. 2a plus 3b over 3a plus 7b. Put it in parentheses so we can see the separation. Plus twice our width, when our width is 4a plus 5b over 3a plus 7. And now we're multiplying this times 2. Each our length and our width. But remember, it's 2 over 1 and 2 over 1. So our denominators are going to stay the exact same because they're both being multiplied by 1. Anything times 1 is itself. It's our numerators that we have to use our distributive property and double, which is going to be easy enough. So continuing down here, we have twice 2a plus 3b. Well, 2 times 2a is going to be 4a plus 6b. And now we're going to repeat it over here. Plus 2 times 4a, which is just 8a, plus 2 times 5b, which is going to be 10b. And now we put the entire expression over the common denominator of 3a plus 7b. Because when we have common denominators, we can group it all together over the same denominator. And now we're going to look for like terms. I have 4a and 8a. So I'm going to bring those together as 12a. So now they're taken care of. And I have 6b and 10b, which is going to be 16b. And now this is still all over top of our common denominator of 3a plus 7b. And now you have the choice. You can leave it just like this because it is as simplified as you can get. Or you can factor a GCF out of your numerator. You can pull out a 4, and you'll be left with 3a plus 4b over 3a plus 7b. But this is optional. Remember, you pull out your GCF to see if you can cancel anything out or simplify it further. But in this case, we cannot cancel out 3a plus 4b over 3a plus 7b because we are unlike. So pulling out this 4 just kind of breaks it down further, but doesn't actually help you simplify it. So this is an optional step, but this is fine as your answer. All right, onwards. That was example 3. So now we're on to subtracting rational expressions. To subtract rational expressions with like denominators, subtract the numerators and write the difference over the common denominator. Recall that to subtract an expression, you add the additive inverse, which is just saying you add the opposite. So let's let's erase so that we can subtract. All right. So example 4. We have 3x plus 4 over x minus 2 minus x minus 1 over x minus 2. Again, common denominator, so you can combine your numerators over top of your one denominator. So you're going to have 3x plus 4, and now minus x minus 1. That entire quantity is being subtracted, so this subtraction sign is going to have to get distributed to every term on the inside because it's not just x that's being subtracted, it's also 1 over top of x minus 2. And now remember, subtraction is just the addition of the numbers opposite, or you can distribute this negative sign and swap every number on the inside sign. Either way, it's the same. So 3x plus 4 minus x, because I'm distributing that negative sign, minus x plus 1, because I'm distributing that minus sign to negative 1. A negative times a negative is positive. So plus 1 all over x minus 2. And now bring your like terms together. I have 3x minus x. 3 minus 1 is going to be 2x. So those are now taken care of. And now I have 4 and 1. 4 plus 1 is 5. Boom, boom. And this is all over x minus 2. Your numerator does not have a GCF to factor out, so that is as simplified as it gets. Flipping the page to our last example, example number 5. I need to get my book closer, that's far away. Okay. Sometimes you must express the denominator of its additive inverse to have like denominators. So, what that's saying for example 5 is sometimes you're going to be given two denominators that are kind of the opposites. They're the same numbers and letters, but one might be positive and the other one's negative. Well, what can you do to make those common denominators is you can use the additive inverse. So for example, number 5, we have 2m over m minus 9 plus 4m over, I'm going to rewrite it so it's in the same order, but negative m plus 9. The denominator n minus m, which is this one, is the same as a negative, which is the same as multiplying a negative n plus m, or just pulling out a negative sign from this one. Recall that the second expression is so that the same denominator as the first. Basically, they're using some kind of complicated language to say there is a negative 1 that's been multiplied in to this denominator. And so what happens if you pull it out? Let's say, okay, you can hear my dog barking upstairs. That's okay. What happens if I pull out a negative 1 from this problem? I'm going to rewrite my whole thing, but I'll have 2m over m minus n plus 4m over, take out that negative 1, so pull out that negative sign right here, because you don't always have to write that m, or not that m, sorry, that 1. Any kind of hovering negative sign has an implied 1 in front of it, so we're going to pull out that negative 1 and leave it as just a negative sign on the outside of parentheses. And by pulling out that negative 1, I have to change my signs. So negative m divided by negative 1 is just going to be m. Positive 9 divided by negative 1 is now going to become negative 9. And now I have matching denominators. Sound good so far? And now that creates, rather than an addition problem, a subtraction problem. This negative sign right here is going to trump that addition sign, because while the original problem was addition, we swapped it to the additive inverse as soon as we pulled out that negative 1, and the additive inverse just means we're adding the opposite of the original. So when we were originally just adding this, we're now going to add the opposite, which means to subtract your original problem. So now again, rewriting 2m over m minus n minus 4m over, and now I don't have to rewrite that negative sign because I've just rewritten it up here, m minus n, and now I have matching denominators. And now I can rewrite it over a common denominator, so 2m minus 4m over top of m minus n equals, well, 2 minus 4 is negative 2m over top of m minus 9. You have no common denominators, so that is as simplified as it gets. And there you go. That is adding rational fractions with like denominators.